Hi, I'm Mike Holloway, a software engineer with Cisco Systems and a longtime open source contributor. Today I'll be introducing and demonstrating an installation of swarmstack, a collection of DevOps tools running in Docker Swarm and providing a monitoring and alerting system that you can use to run and operate your own container-based applications at scale. Swarmstack is targeted for development groups as well as enterprise users with needs like LDAP authentication or labs requiring web proxies to reach the internet. Swarmstack builds on the Prometheus monitoring ecosystem, providing alerts through Prometheus Alertmanager, dashboards and data visualization through Grafana, and deploys Google CAdvisor and NetData to collect telemetry about the health of your applications and the swarm hosts running your containers. Here you can see me first provisioning some Google Cloud Compute Engine virtual machine instances. If you'd rather just see the DevOps tools, go ahead and skip to about minute 15, where I'll demonstrate each of the web UIs for the tools that make up Swarmstack. I'll give you a tour of the tool UIs and talk about how the tools fit together to support you or your DevOps team in monitoring applications and Docker containers running at scale across hosts. Last, I'll briefly talk about doing a little chat ops with another Swarmstack project called Errbot Docker, which easily integrates with Swarmstack and can help direct alerts about your applications into different social networks, channels, and webhooks. Deploying a Swarmstack in Amazon would be similar to what I'm doing here, with an additional EBS volume being attached to each EC2 instance, providing the additional storage devices or partitions that Portworx can use to provide high availability volumes across all of your Docker hosts, Swarm hosts. Swarmstack has also been tested with bare metal CentOS 7 hosts, as well as within VMware ESX and VirtualBox. Swarmstack should deploy to most cloud providers or locally hosted virtual machines, whichever best suits your needs and experience. Quick word about security. I've skipped over the configuration of the Google Cloud Firewall rules. You'll need to make some of your own decisions there, but Swarmstack will at least handle for you the firewall management on all of the hosts in the swarm. Least I can say here is that a multi-tiered system of proxy servers or cloud provider load balancers terminating the TLS traffic and retransmitting it again over HTTP and HTTPS into your separately firewalled applications or Docker containers is one known security pattern and provides layers of protection for your applications and data. Swarmstack adds security by working with the Docker daemon to configure the firewall service on each host in your swarm to permit only the right traffic into your applications. For better security, any additional hardware, software, or cloud provider firewalls placed in front of the physical or virtual hosts would also help enforce this path so that the traffic to the swarm hosts can only come from, at most, compromised proxy servers attacking your applications and the Swarmstack tools via their web ports, which are themselves protected by a caddy reverse proxy server. During the Swarmstack installation, you'll see that fail2ban gets installed on each host, which will help prevent brute force attacks against the SSH daemon, and you can also use it with your own applications to secure them from logged authentication failures. SSH traffic is permitted to all hosts by default when performing Swarmstack firewall management, but you can change this default behavior or make any necessary firewall configuration changes by editing Swarmstack template files used by Swarmstack's Ansible playbooks. One of the features of the caddy server, the reverse proxy server used by Swarmstack, is that it can automatically manage TLS certificates for you, whether using self-generated certificates, which is the default, or by automatically registering and managing free Let's Encrypt web certs for you, which are now honored by most major browsers as a trusted root CA. You can also provide your own web certificates and have Swarmstack install them for you into Caddy. All the tools installed by Swarmstack will be secured behind Caddy. All other access will be blocked by proper configuration of any upstream firewall, and also by the Swarmstack managed firewalls on the hosts. After configuring the instances to be able to access each other over SSH, including any necessary cloud provider firewall settings between instances, Swarmstack is installed by first cloning its GitHub repo to either one of your eventual or existing Docker manager nodes, or to a node with SSH access to a Docker manager node. Then creating a local copy which any configuration changes can be made to. You'll edit the Ansible cluster template file and add your host names and some Swarmstack cluster and storage settings, as well as the cluster firewall template file to at least permit traffic between all hosts in your Docker swarm. Finally, you'll run up to 5 Ansible playbooks across your swarm hosts, depending on whether you're installing Swarmstack to an existing Docker swarm or a new one. Swarmstack will automatically detect Docker existing swarm nodes, if they exist, and will automatically install Docker and join all hosts not already running Docker to the host you define as the Docker Manager swarm join host. If this is an existing Docker Swarm Manager node, swarmstack will ensure that all hosts defined as swarm group hosts in the cluster are joined to that existing swarm ID. If the swarm join host is an unconfigured or an uninitialized Docker host, Docker will be installed if necessary and a new swarm ID will be initialized. All other hosts that are defined as swarm group members will leave any old swarm ID and move to the new one. Swarmstack will also optionally install Docker service firewall template files that can lock down container service ports, such as your applications or to the Swarmstack tool ports served by Caddy from only certain IPs. By default, Docker ports exposed by swarm services are accessible from any host within the swarm, and Docker will proxy the traffic to the host running the container exposing that service port. Since this traffic enters the Linux kernel firewall through the forward chain rather than the input chain, simply blocking exposed Docker service ports on the firewall input chain won't block their access. Instead, Swarmstack can manage a separate forwarding chain called Docker user, which Docker will place early in the forwarding chain before reaching Docker swarm forwarding rules later in the host firewall. Swarmstack currently uses IP tables rather than firewall D, and will install IP table services and mask off firewall D, although both are equally capable of programming the kernel firewall chains, and you can re-enable firewall D if you need to. Now that we've finished checking that the hosts can reach each other and have a known root password, we'll clone the Swarmstack GitHub repo and make a local copy. We'll make our configuration changes to the local copy and can add our changes to a newer version of Swarmstack as they become available. Following the instructions under the installation section of the Swarmstack README on GitHub, we'll first add our new Swarm host to the Ansible cluster file. You can create separate copies of this template file under other cluster names if you want to manage several or even many Docker Swarm clusters from this host. You can copy your cluster files to multiple hosts or commit them to source control and use them from any host with network access to the Docker Swarm host. I've added 3 hosts to my Google cluster called Swarm 1, 2, and 3, so I'll add them here to the Ansible Swarmstack cluster file. When it comes to defining the external endpoint, here we'll just use the IP address externally available of one of the instances. However, this would likely be a DNS address that you control. This address is used by links that are sent out to emails generated by Alertmanager or between some of the tools, especially if you're doing chat ops. Swarmstack will make changes to the sysctls controlling some of the network parameters on your Docker Swarm hosts, depending on the memory settings that you define in the Ansible cluster file here. With the example hosts on Google Cloud here, I have about 4 gigabytes per machine, so I'll put them all in the 4 gigabyte memory group. When defining the hosts that will participate in the Portworx storage group, pay attention to the devices that they're contributing, here dev SDB, and also the names of the network interfaces. If you're using bare metal machines and wanted to improve performance, you could have additional Ethernet NICs and define separate data interface and management interface, network interface adapters here. Now we'll configure the firewall rules to at least permit instances to talk between each other. Here I'll permit the entire 10.128 network to communicate with each other. If you explore the Ansible roles directory, you'll find a common directory that also has a common firewall configuration that's applied before the host configuration of the firewall or the Docker firewall rules, and you can make changes to that file as well as needed. By default, that common firewall configuration template permits SSHD traffic from all hosts. Finally, we configured the Alertmanager configuration, which can provide destinations for your alerts, either to email addresses or to social networks that are supported natively by Alertmanager, or as a webhook target into any infrastructure you like, or possibly even an Errbot that's available to connect to additional social networks that aren't supported by Alertmanager directly. Now we're ready to run the Ansible playbook that configures the firewalls on all of the Docker Swarm hosts. You'll want to do this step even if you're bringing your own Docker Swarm. It really is a pain to manage the firewalls correctly, so having a Ansible playbook that can do that for you and is aware of Docker user firewall chains is helpful. Now that we've run the firewall playbook, we'll run the Docker playbook, which will install Docker on all 3 hosts and initialize a swarm and bring all the hosts into that swarm. You can rerun the Docker Swarm playbook anytime you'd like to add additional hosts. One of the things that the Docker playbook does is to upgrade all the packages using yum. It will detect if the kernel is updated and reboot the hosts if need be. It'll do that in a serial manner, so it'll take one host at a time as it works through them, and containers can move around on their own as the Docker hosts are being upgraded. So the Docker playbook is not only for installing Docker on hosts, but it also winds up being your upgrade script. Here we see the 3 Docker hosts that join the cluster. Now we'll run the optional etcd and Portworx playbooks, which will install high availability etcd that Portworx will use to store storage metadata in, and then we'll run the Portworx playbook to install Portworx across these 3 hosts. Looks like etcd is up, so we can move on to installing Portworx. Portworx runs on bare metal or virtual machines as a container, in this case installed as an OCI container outside of Docker so that it doesn't depend on Docker, and allows you to share storage devices between different hosts contributing into a common shared storage cluster, which Portworx will then work with Docker to carve out volumes and transfer those between multiple hosts, keeping high availability of the volumes, as well as being able to move between Docker Swarm hosts very quickly. And we can see our storage cluster came online, and 3 hosts are contributing their 50 gigabyte disks into a 150 gigabyte storage cluster. Docker natively can support Portworx through its socket file that it publishes in a common format that Docker recognizes as a storage plugin. Now that we have persistent storage available, we're ready to execute the final Ansible playbook, which installs the swarmstack DevOps tools as a stack. Some of the containers require persistent storage so that deleting the containers or the stack later and redeploying swarmstack will provision new containers, but with the persistent data directories being mounted in the right places, so you can take down your swarm and then bring it back up at any time in the future, and it'll pick up right where it left off. Now that the swarmstack containers have been deployed, we can do a docker volume ls and see the storage volumes that Docker created for us using the Portworx driver. We can also see that the containers are starting to come online on the various hosts. Before we take a look at the web UIs of the tools, I just wanted to show you some utilities that you can copy into a directory within your path to more quickly list running Docker services or the containers running on a host, or even enter into a container through its bin shell or bash. So now that we've deployed the swarmstack containers, we'll pick up the external endpoint IP address and point our browser at it. If you have opened up the HTTP port, Any traffic received by Caddy on the HTTP port will automatically be redirected to the HTTPS port, which, after authenticating with the admin password you specified, should give you a list of links to all the different tools that swarmstack's deployed for you. All those links are going to be relative to the Caddy proxy server. So they'll point at that Caddy proxy server, which will then actually be proxying the data to the correct tool inside a overlay network inside Docker Swarm. This overlay network is encrypted and provides further security for the traffic that's moving between the tools. First, we'll take a look at Alertmanager, which is one of two alert managers that swarmstack will deploy for you. These are the targets that Prometheus will send alerts to, and they will work between each other to deduplicate alerts. So the idea is that Prometheus, when it has an alert to send out, will send the alert to both alert managers and then let them work out between them which one will actually send out the alert, using a gossip protocol between the two to deduplicate. We'll skip over Grafana for a moment and take a look at netdata. A copy of netdata is installed on each host or virtual machine and collects various metrics from the Linux kernel and performance of the disks and networks. That data is made available to Prometheus, and it's also available through a real-time web UI that Caddy will proxy. So this is one of the few parts of swarmstack that runs outside of Docker. That would also include etcd and Portworx, and netdata will run by systemd on each of your hosts on port and expose port 19,999, which hopefully your firewall rules are blocking, so no one can get to those tools unless they were on the local host. And then you'll receive traffic to them via Caddy by connecting to your Caddy server on port 19,998, which will proxy the web request to the correct netdata server. Now we're looking at Portainer, which is a swarm management tool. It can manage your Docker hosts and provides a GUI for your users potentially to deploy containers through. So you can create templates and have Portainer go deploy them for you on the Docker host without ever touching the command line. You can import different repositories and also check on the status of your swarm. There's a cluster visualizer that'll show you all of your Docker hosts and what containers are running on each. You can see what ports are being exposed by the different containers and what host they're running on. Now let's take a look at the Prometheus interface. You won't spend a lot of time using the Prometheus interface other than to develop PromQL queries. We can look at the status of Prometheus and see what targets it's scraping. Here we can see they're all up. This is where Prometheus is ingesting all of its data from. And you can explore various PromQL queries just by starting to type in this field. As you type, the available data points that have been fed into Prometheus time series database are highlighted for you. And you can use this to develop queries and build Grafana visualized graphs out of them later. So I've executed a PromQL query here and visualizing it in a tabular format and also in a graph format where it'll take the different elements and graph them for you. Now we'll take a look at the Prometheus push gateway, which generally you won't use the web UI a lot for. The push gateway is used for pushing ephemeral and batch job metrics in that aren't around long enough for Prometheus to come by and scrape on a regular interval. But it also provides a web interface where you can use to debug and see what data is being fed in that Prometheus will come later scrape from the push gateway. And now we'll look at unsee. Unsee is configured to watch both of the alert managers from a single window. So if you had a knock or a screen, you could just leave unsee running here, and any of the alerts that are live in the alert managers or even the silences that you've configured in your alert managers are available from that one unsee screen. Finally, I'm going to just give you a look at some of the Grafana dashboards that are provided by default with swarmstack. These will help you run your cluster and help you keep track of the health of the swarm hosts as well as the containers and the amounts of bandwidth that they're using and disk space. Also, Portworx volumes are monitored as well as Prometheus's internal metrics. So just take a few moments to look around at all the different metrics that swarmstack is going to provide you here. And the idea is that you would add your own applications into Prometheus monitoring and then come into Grafana and build any visualizations that you like from that data that's being collected in the time series database in Prometheus. So I've actually fixed a bug here where the volume latency is shown with no data points. There's a difference between the Portworx developer version and the Portworx Enterprise in the Grafana graphs. So these particular screens here were developed by Portworx for Grafana. I took them and customized them for swarmstack and tuned them up a little bit. But there are additional Grafana dashboards that you can download from Portworx if you're running the Enterprise version. You'll notice the URLs for the different net data servers change very little, only by a prefix in the beginning. And that's because they're all handled by the same port 19,998 on the Caddy server and then proxied to the correct destination host. And since we've already logged into the Caddy server on that particular port, we don't have to re-authenticate to access the other host's net data. So now I'll take you back to Prometheus and just show you one more screen that I didn't show earlier, and that's the alert screen where you can see all of your alerts that you have configured, and you can click on them to expand them. If any alerts are actually in violation or raising an alarm at the time, they'll display in a different color there on that screen. But you would probably be watching unsee or maybe your Alertmanager instances to actually see the alerts pop up in real time. So as I close, I'd like to point you to the GitHub project, github.com/swarmstack, and we have a project called Errbot Docker. Now, Errbot Docker is optional, but if you find that Alertmanager doesn't support the social network that you want to send your alerts into, have a look at Errbot Docker. Errbot Docker provides a container image of a working Errbot, which you can connect to different social networks that Alertmanager might not support natively. I'd like to close with a big thank you to the community for its support of this project. I've reached out to several of the tool vendors and received support, bug fixes, and updates in order to get this project to work. If you have a feature you're looking for that you think might have a generalized fit with the swarmstack toolchain, open up an issue on the related GitHub swarmstack project page and we'll consider it. Thanks for your time and hope you have a great day.